Okay, this video is going to help with 4-6, and this is matrix equations and systems of linear equations. So basically, how are we going to use this inverse that we've been doing in the last section to solve a system of equations? Okay, so if the coefficient matrix has an inverse, then the system has a unique solution. So remember, the coefficient is just what's on the left versus the line and then the numbers over here when you're in the augmented form. But when you have that 2 by 2 or that 3 by 3, if there is, oh goodness, if there is an inverse, then you have one unique solution. Okay, so we are given our original matrix times x, which is usually it usually goes matrix x like in a row. If that equals b, then we can say that x is equal to the inverse times b. So what does that mean? It means I can take the inverse and times it by what's usually on that right side, those numbers, and get the solution. So take a second, write down this right here. So basically what I'm saying, if I have a times x equals b, okay, so A is a matrix, B is like our answers, and these would be X, Y, X1, X2, whatever we want to call the letters. Then what we can do is we can find the inverse of this part and times it by the numbers over here and get our solution. So my work right here is doing the inverse by hand, using the determinant because it's a 2 by 2. 8 times 5, 3 times 3, subtract those, I get 31. Then I switch these two, change these signs, and divide them all by 31. Ew, that's my inverse. Okay, what's another way you could have gotten that inverse? You could have done the original and then done the identity, right? A line and then the identity, 0, 1, or 1, 0, 0, 1, and then done row operations. Could have also used your calculator. I'm not even tired. I can't stop yawning. Okay, so once we find the inverse of this, I can times it by this, and I can get my x1 and my x2. So here's my ugly inverse, and times it by this one. So we're going to go this one times this. You can use decimals, it's fine. This one times this, which is right here. And that's going to add those and get my top number. This one times this one times this one, add those and get the bottom number. So the solutions to x1 and x2 are 1 and 2. What did I do again? Inverse times the numbers that would have been on the left side of our original equation. Okay, so let's look at a 3 by 3. So let's say you were given this right here. I know I skipped one problem, but let's say you were given this right here. So you're given x1, x2s, and x3s. Let's put that in our left side in our coefficient matrix. So it would go 1, we don't have an x1 here, so 1, 0, 2, 1, 0, 2, negative 1, 2, 3, negative 1, 2, 3, 1, negative 1, 0. So that's our coefficient matrix. And then we're going to take and find the inverse of that and times it by the 1, 1, 1. Okay, inverse, use calculator. 3 by 3, the inverse is going to take us a while. So when we put it in our calculator again, we put this in with the 1, 0, 0, 0, 1, 0, 0, 0, 1, right? That identity matrix over here. You push reduced row echelon form, and you will get your, holy cow, I can't stop yawning. You make fun of me in my video here. Okay, so, and then we could get our inverse. All right, so this one's inverse. Now, what else can we say again? Oh, if I times these two together, I better get back out the identity. Okay, so that was to check if they really are inverses of each other. Over here, we know our x values are x1, x2, x3 in a row. This is our inverse, and we're going to times it by the 1, 1, 1. So remember, again, you have to go this one times this one, this one times this one, this one times this one, add them all together to get each number. So that matrix multiplication. In a business context, why would this be handy? Actually, business is the only place I could think of that this would be handy. If you have set prices for items and you want to play around with how many you sell each day, or trying to think of a good example. But anyway, there's a lot of places that you could change those end numbers, and you already have the inverse, so you just times. And you could set that up to times in a calculator as well, so, or in a program. So this does have context for a business. So here's our X1, X2, X3. Okay. So my next little piece here is, what if I change B from 1, 1, 1 to -3, 0, -1? So for whatever reason I change it, then all I have to do is multiply it again by the inverse, always having your numbers be second, and you would get out your answers for the new one. They do ask a couple questions on the equation. I really want you just to focus on using the inverse, but there are a couple in there for your sake. Basically, no division is allowed. So if you start with this original matrix times the x is equals b, you cannot divide over or anything. So we have to use that inverse. Okay. And I don't think, you also can't, I mean, it has to be a square to use the inverse on your coefficients. You do have this list of theorems. Here's the thing. These are properties that are allowed with matrices. So I'll hold it to the top. This is straight out of your book. Oh, okay. I was like, it won't let me. So here's the top part. If you want to put some of these in your notes, you can, but I'm telling you right now, this isn't what we're focusing on. We're going to use our inverse to solve our systems, and that's what will be on your next exam. And then here's the bottom half, if you want to pause and get that down. Okay, those are just our different rules allowed with matrices. So really, for this section, what are you doing? You're finding that inverse using a calculator, and you're timesing it by the numbers that it would equal, and that's going to give you your answers. All right.